Yeah. I believe at that time, oh, why is this speaking up? Let's see. Okay. Yeah. So I believe at that time there wasn't, that there's a voice here. Oh. Hello. Yeah. Yeah. I still hear myself. Oh. Oh, okay. Wow. Anyway, yeah, let me start. Hello? 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 Yes. Yeah, so at the time, there wasn't too much work that was done in this area, and in 2019, then, quite a fair bit of work has popped up. I suspect it's not my machine.
It's making noise and it's on mute.
Oh.
It's muted, guys. Yeah.
Hello? Testing. It's from my machine? Yeah. Okay, let me test again. Yeah, it's good now. All right. Yeah. So, yeah, what I'll be talking about for this collaborative machine learning is this part about incentives and data valuation. Back in 2018, I actually heard about two different companies wanting to collaborate, and to my surprise, they are not friends, right? So this is, however, they see mutual benefits to it. Each party wants to improve their own payoff, but the question is whether they can still collaborate as self-interested agents. Okay. So this is one of the motivating scenarios that many of you have seen. Well, in Singapore, we actually have 3 different hospital clusters, right? And over there would be a central agent whereby it could be our Ministry of Health, right, that tries to coordinate the sharing of data between these 3 different hospital clusters. Now, of course, for each of these hospital cluster, you can imagine that they are self-interested in nature. They want a predictive model that can help their own patients within the hospital, right? But it could be private, right? Those hospitals could be private. Now, this Ministry of Health is trying to help them to build models, right, such that compared to the model of their own, they are able to obtain an improved model by sharing their data with this central mediator, right? And, one of the aspect or perspective that we want to propose here is the notion that if a certain party is willing to contribute data of more value, then in return, that party should get back a model that is better than the others, right? So this is the notion of fairness that we are talking about. I would be more concrete in terms of what that fairness means. Now, some may ask, like, why not the money, right? Why not give out money? Instead, why are we interested in giving back improved models? So especially in the hospital context, I think their interest is actually getting back an improved model than money. Secondly, yeah, sometimes it's, you can ask David, sometimes it's hard to determine what's the budget, right, up front. You're going to tell the one who's going to give the money how much you need, but how do you quantify how much you need? That's going to be hard, yeah? So we look into model rewards. Towards the end, I can tell you about all the various types of rewards that we have looked at, okay? All right. Now, this is not pertaining to only the hospital setting. In fact, in Singapore, we also have what we call the urban farms, where they can collaborate as well with their agricultural data. Okay, so to summarize, you will see that all these individual parties have limited data, especially in Singapore. We don't have that many patients per hospital, right? Now, however, if you try to aggregate data from all these different parties, it allows you to build improved models. So now, why do these data owners, why do we need to incentivize them to collaborate, right? Why do we have to do that? It's because often they incur a certain cost to be able to obtain that data, right? Therefore, they are looking for such some form of rewards for them to participate. And as I've mentioned, we advocate the perspective of fairness, right? Where you give more valuable data, you actually get rewards that are more valuable. Now, I've also mentioned about why we don't want to be monetary in this case, right? I've already mentioned the reasons. And finally, yeah, we want to give back models as rewards. For now, I'll call them model rewards. This is practical, right? Because all the different parties care about getting an improved model. And interestingly, it is freely replicable. That means using the same data, right, you can replicate another model without an additional cost. All right? So this will be what we care about. Now, what may be slightly different from the other talks that you have heard about is that we are thinking about what are some of these incentives that people may care about that helps to encourage collaboration. So I'm going to name them one at a time, right, and see all these different properties of the various incentives that we want. So 3 key questions in this entire framework. Now, first and foremost, before I can talk about incentives, one of the problem that I face is that now I need to ascertain how valuable is your data, right? That's my very first step. And that's where I needed to talk to David, right? On how do you value a party's data. Now, from my own experience, there's no one valuation method that's suitable. It really depends on the context. That's at least what I've learned. But in this context of the slides, I'm going to show you just one form that many will be familiar with. Then the second question is, after you have valued the data, how do you design a reward scheme, right, to decide what's the value of the model rewards that each party is going to get in order to incentivize them to collaborate? And finally, how do you realize, given the values of the model rewards, how do you realize the model as the reward to be given back to the different parties? So you can see here that these are the 3 questions: data valuation, incentives, and finally, reward realization. Okay, I'll talk briefly about data valuation. And in this case, I'm going to pick one that, at the start, we actually ask ourselves, now if the valuation method needs to rely on a validation data set, isn't this going to be hard across different parties? Why? Because different parties may have different preferences for what the validation data set could be going forward in their future predictions. They may have a different distribution of points they want to predict in. So this is something that seems like it's hard to agree on a certain validation data set. Now, are there other valuation methods that don't rely on a validation data set? Now, one could look at information gain on the model parameters, right? This is where we look at information gain on the model parameters, right, given the data that you have. And the way we value it is like what you have seen there, right? Oops. Yeah, what you've seen in this quantity. I'm trying to gain information on the model parameters, right, given the data of the group of parties that contribute that data. All right? Now, the underlying idea is quite simple with information gain or mutual information, right? If your data provides more value to the model parameters, it means that there's a greater reduction in the uncertainty, right, in the entropic sense. Okay? And because of that, through marginalization, you can actually get a better expected predictive accuracy. And hence, this means that your data is more valuable. Now, there are other interesting properties, like, for example, noise actually causes the value to drop, right? So this comes with interesting properties. Now, then what about the incentives? Right, so you have this central mediator who is going to go about valuing the data of each party, and later on, like what David has mentioned to you on the Sharply value, they are going to compute the individual Sharply value for each of them. That's denoted by this phi. And then, using that, we are going to decide what's the reward that will be given, right, to each of the party. Now, like I've mentioned, I want to achieve fairness, and because of that, we have to be careful in what we select to reward the party, right, so that it will be commensurate to the value of their data, right? Later, you're going to see how that's done. Right? So this is the overall process, but in order to get there, after I've valued my data, what kind of incentives should I consider? Right? This is the one that I tried to list. Okay, so over here I'm going to say that the ideal case is that I want all the parties to collaborate in a grand coalition. Right? That's the case. And later on, we will see this stability incentive. Right? How do we ensure that the grand coalition stays stable? Now, I'll probably skip the first one, right, the first incentive. The second one is efficiency. Now, we want at least some party to be able to get back a model that's as good as the model that's trained on everyone's data. Now, if that's the case, then you know that the data won't be wasted, right? So that's the efficiency. And rationality, this is the one where I think most people care about, individual rationality. You want to ensure that by collaboration or by collaborating, you get a model that's better than your own, right? Now, in this, the R2 and R3 incentive, we have actually modified it from the cooperative game theory perspective, right, for it to fit into collaborative machine learning. Now, finally, the fairness incentive, right, that I was talking about, the more you contribute, the more you get back. So how do I do that? Now, there are a bunch of properties that you can keep adding to make it look like it's more fair. But these are the 4 that we have picked. Now, the first of all is the one where, if your data does not actually improve any model formed by any different parties, then you know that the data is useless, and therefore this party should get back a model of no value. Right? Now, secondly, how do we know that two different parties, right, they should be valued similarly? Now, when the value of the data, right, it contributes similarly to models that are built, right? Therefore, they are symmetric. Now, usually with these two alone, you can sort of think, it's fair, right, in this case. But there should be more. How do I know one party is more desirable than another in terms of their data, right? This is something that we have actually defined in math, but I'm writing the words here, okay? Now, comparing these two parties, if there exists at least one group of parties where this party's data can improve the coalition more than the others, while everything else stays the same, then we say that this party is actually more desirable. Okay? Now, besides that, we also want to ask the case where, now, how can a party be incentivized to contribute more of its own data? Right? This is the one where we have the monotone property. So if the party contributes more data, it can result in an improvement in the model, right? Then this party should get a higher reward back, right? That's the monotone property. So with these 4 properties, if they are all satisfied, then we say that it has this fairness incentive, all right? Okay, now the last 2 properties, desirability and monotone, they actually depend on this thing on marginal contribution, which I think David has mentioned before, so I wouldn't go into it. And the outcome is that Shapley value is going to satisfy the properties that I've mentioned. There's also this stability incentive, right, where we don't want any sub-coalitions to run away and form by themselves, right? So this is the one where you also want to guarantee that the grand coalition is going to stay stable. I won't elaborate about that. But it's possible to check for stability efficiently. Okay, now the last one is what we call the social or group welfare, which is what most people would care about if you're in economics, right? So, however, think about in our case, if I'm able to maximize the group welfare, it means that every party is going to get back the same model. That's equality. That's actually unfair, right, in our opinion, right? So we want to try to give as much as possible, but instead of giving everyone the same model. That's equality. So we try to increase as much as possible, but don't fully maximize it. Okay, now in terms of the reward scheme, what should we use? Previously, I've mentioned Shapley value, but if we are going to use a Shapley value as a reward, it's not going to satisfy the efficiency incentive, right? Because when you try to sum up the Shapley, it's going to be exactly the same as that of all the parties put together, right? Same value as that. But remember I mentioned that in efficiency, we want at least one party to get the best model as the one that's formed by all the parties together, right? So it doesn't satisfy that. So what do? We revise it so that it's strictly proportional in this case, such that the best party, right, that gets the highest reward value is going to get the best model. However, in this case, even though the efficiency is satisfied, rationality may not be satisfied, right? For certain parties, whatever value they get, it might not be better than their own, all right? So what we do is to include a power parameter that's used as a trade-off called rho, right, that we put on top. Right, this is the trade-off parameter. Now, in this case, we can vary rho depending on what you want. If rho is 1, it's going to be exactly that of the Sharpley value. That's Sharpley fair. But if rho is 0, that's going to mean equality. You give everybody the same model, right? Now, of course, when you give everyone the same model, rationality is preserved because everyone gets the best model. It's stable. Everyone is happy with the same model. But it's unfair, right? So it should allude to the fact that, hey, I should have a rho value that's sufficiently small, but not 0, right? That will still be fair. So this is exactly what this diagram is showing you. In this big box, it's going to satisfy all those efficiency, feasibility incentives. And then what we really want to clock would be this gray region here, where all the incentives that we have specified so far will be satisfied, including fairness, rationality, and stability. Now, if you have a stable solution, then naturally it will be individually rational. Now, of course, that's done with decreasing rho, okay? Of course, we don't want to decrease it all the way to 0. That would be equality and therefore unfair. Now, of course, at the same time, if you decrease rho, it's going to increase your group welfare. Everybody gets more. Now, if your better off agents or parties want to be more altruistic, right? They can actually decrease rho to allow the weaker parties to benefit more. Okay. Now, in terms of how do we realize the reward for each party so that it's commensurate to the value that the value of the data that they have, this is the part where we use a very simple noise mechanism to add to the data. Right? I'm not going to elaborate on that. Okay. All right, I'm going to skip the experiments and go straight to the take-home message. Oops, okay. Now, earlier on I mentioned to you the goals or the various incentives that we want to satisfy. Right? You've seen fairness, individual rationality, something that we can get back as a better model than your own. Right? We also allow you to achieve stability if you control that trade-off parameter to be sufficiently small. Now, we have chosen the path of non-monetary, right? And what we don't have yet, but we have it this year, would be that of an incentive that is not game theory inspired, right? Instead, we look at this notion of the privacy incentive, right? Can we actually give the ability to each of the parties some way of incorporating differential privacy to their own data? And then what's the trade-off when it comes to how does it affect all the other incentives? Yeah? So that's something that we have this year. I can talk to you more at NeurIPS, where we have that paper. So you can see from this list about the various things that we have done. I've mentioned to you that just now by incorporating the privacy incentive, right, that's the one that is in the NeurIPS 2023, right? This is something that we are very excited by because we can have a privacy incentive to be able to, trade off, right, with the other incentives that we have previously developed. Now, there are also other things that we have considered. Like, for example, just now I mentioned no monetary, right? But what if they want to spend some money to buy a better model? That's where we have a trade-off between payoff and model rewards. I've also mentioned to you all the various rewards that you can get. Just now, I've just told you about giving a model as a reward. But what if some parties want synthetic data that's generated from the raw healthcare data? That's the one that you can see there. Now, some of you may argue with me, but you should give everyone the same model and the best model. Why can't you do that? So yes, we have done something like that as well. We call it fair yet asymptotically equal. That means over the time, we are always trying to be fair in every iteration, but in the limit, everyone is going to get the same model. So it's able to achieve both, right, in this sense. Now, what's also interesting would be the case that, for some of these algorithms that you have, like federated learning, there will be iterations. And in each iteration, we want to ask, hey, what does it mean to be locally fair? How is it going to affect you in the global sense? So these are some of the works that we have looked at, right, where locally fair can imply global fairness, right? So this is some works that have been done. And finally, right, as an advertisement, this is just out this today, right? We want to also ask the question, what if somebody has the rights to withdraw their data? And that's where we looked at data valuation where it is deletion robust, right? Can I actually compute the Sharpe value prior to them deleting, right? Okay, that's all I have. Sorry. Thanks.
Brian? Cool, let's thank the speaker again then.
Thank you.